All right, so welcome to our first full example of a two-sample um, hypothesis test for proportions. So example one reads, the Pew Research Group conducted a poll in which they asked, are you in favor of or opposed to the death penalty as a general policy when the crime was committed while under the age of 18? Of the 580 religious persons surveyed, 180 favored capital punishment. Of the 600 who are not religious, 238 favored capital punishment. Is there a significant difference in the proportion of individuals in these two groups who favor capital punishment? Use the alpha as 0.05 significance level. All right, so hopefully you internalized all of that information. Our first example is quite controversial here. We know that capital punishment is the death penalty. So we're asking, how do people feel? Are you in favor or opposed to capital punishment, even when the crime, that this person is convicted of, even if the crime was committed while this person was under the age of 18? So we have a very controversial topic here. The first thing I want to point out is that asking, are you in favor of or opposed? That's a qualitative variable indicating that we will definitely be talking about proportions. So this helps because now we know that my parameter will be a proportion. We know that the conditions will involve NP1 minus P greater than 10. We know that the command will be proportion stats, and we know the distribution will be a normal distribution. With all of that said, I'm going to go ahead and just quickly write that out. We already know the parameter. Now, there are two groups, right? So we need to ask, what are the two groups? I tend to just select the group, whichever one I read first. So of the 580 religious persons, so I'm going to say that's going to be one of the groups. So that'll be group one. And then the people who are not religious will be group two. So my parameters, it's actually the proportion of success in those separate groups. So I'm going to call P1 to be the true proportion of religious individuals. Oh, they use persons. So let's try and always mimic the language. So maybe not religious, maybe let's individuals, let's use persons. Religious persons who favor capital punishment. And really they should say even when the crime was committed while under the age of 18. That's a lot of writing, so we'll stop here. Hopefully you guys get the point here. So whenever we see P1, we're going to be talking about the proportion for religious persons in favor. P2 would be the true proportion of non-religious. All right, so there is our parameter. Now let's go ahead and set up the hypothesis. So the question that they're asking us is there a significant difference? Whenever you see significant, that's statistically significant. So we're just asking, are these attitudes different between the two groups? I want to say that it doesn't take a statistician to potentially say yes, because it's like religion versus non-religion. Usually religion has a lot of teachings on life and what to do regarding human life. So I want to say right away that we're pretty sure there will be a difference. What might be more interesting would be the attitude between religion, specific religions. So that might be more interesting to see. Okay, so again, this problem's not super surprising, but it is an interesting topic. All right, now let's go ahead and write out the hypothesis then that they want us to test. It's clear that this would be not equal to hypothesis test. So let's write that down. The hypothesis test will be, is P1 equal to P2? So remember, null is always the no change hypothesis. The alternative, which is what we are more concerned with, is how do P1 and P2 relate? And we've seen that this is a not equal to, because they're asking if there's a difference. Now, because we're using StatCrunch, I'm going to go ahead and just write these. These are equivalent where P1 and P2 are on the same side. So StatCrunch will say P1 minus P2 is 0, and P1 minus P2 is non-zero. All right, so we've got our parameter, we've got our hypothesis. Now let's check the conditions. So are all the conditions met? So are the requirements met? And for this, I'm going to use a different color. So remember, we need to do this for both groups. So let's do it for population 1. And that was the religious individuals. So let's do the check for religious people, and then we'll do it for population 2, which is non-religious. We'll try and fit it all here. All right, so for group 1, do you have a simple random sample? We're going to say that's safe to assume. Do we have independence? Is my sample size 1 less than or equal to 0.05 times population size 1? Let's summarize the samples here. We actually surveyed 580 religious individuals, and then the number of successes there was 180. This means that we can find the proportion. So P1 hat, this is going to be important. And that's, remember, X1 over N1. So that's 180 over 580. Throw that into a calculator, see what you get. I believe you get 0.31. So just throw it into a calculator. So that's the sample proportion of religious individuals in my sample that support this. So when I go and check the conditions and it's independence, N1 is 580. It's safe to assume that 580 is less than 5% of the population, because we're essentially saying the population is extremely large in this case. It's several million people. All right, now comes the shape requirement. So for the shape, we need to check N1 times P1 hat times 1 minus P1 hat. Is that greater than or equal to 10? Obviously, the answer is going to be yes, otherwise we can't proceed. So we can just verify that. Please practice using a calculator. And so if you didn't find P1 hat earlier, this is what tells you, hey, you got to find P1 hat, the sample proportion of success in your first group. So this ends up being about 124 something. So that's definitely greater than 10. So that is met. I'll go ahead and ask you to please go ahead and verify the requirements for the second population. All right, hopefully you verified this. We found that we will still need to find SRS independence and the shape requirement, but this time we're doing it for the second population. That was the population of non-religious individuals. So there were 600 non-religious individuals. Of those 600, 238 favored capital punishment. And that gives me a point estimate of 238 over 600, which evaluates to 0.4. So the proportion favoring capital punishment is higher, at least based off of my sample, in the non-religious persons. All right, so now that we've wrapped that up, we can see that the requirements are met to say that each separate proportion sampling proportion behaves normal so that when I combine them, the central limit theorem that was cited earlier still holds, and we can just simply go ahead and proceed as usual. All right, so I do want to make a sketch just because I don't have one here. So let's make a sketch. Number 4, let's sketch. And I'm going to go ahead and sketch a standard normal distribution because it's proportions. And notice that we have a not equal to alternative hypothesis. So this means that we're doing a two-tailed test. The significance level is 0.05, so standard level. So I'm going to go ahead and shade my two tails right away. Each tail has an area of alpha over 2. In this case, it'll be 0.025. And therefore, we can find the critical values right away. All right. So to find the critical values, we have a nice little drawing here. So let's just recap that whenever you have a nice little drawing like this, a distribution, and you have most everything labeled and you're just trying to find one object, you can always use StatCrunch. You will go to Stats, Calculators, and then you select your distribution. In this case, it's normal. I'm not going to change the mean or the standard deviation because I have a standard normal distribution. And now I'm going to go ahead and update the area. So the area that we have, technical difficulties. Let me see if I could type this in. 0.02. Oh, and it did not work. It was not working. All right, finally working. And we want to make sure we swap this over to the right-hand side. And we've got our critical value. I want you to note that just like before, this picture matches my sketch on my paper, which is verification that this is correct. So the critical value is 1.96. And now we can go ahead and find our test statistics. There are formulas for these. I'm not going to give them to you because we're not using them. So we're just going to go ahead and use StatCrunch to get our test statistic, as well as the p-value. All right. So now that we have this here, we can go and use StatCrunch and feed it the sample information. So we're really just going to need this right here, as well as the hypothesis. So remember, population 1 is already selected. So please make sure that you keep that order there. So because this proportion, I'm going to go to proportion stats, 2 samples, with summary. So notice how StatCrunch already is asking what is sample 1. Keep the order. Sample 1 was 580 and 180. Number of successes was 180. The sample size was 580. And then we do the same thing for the other one. I believe this was 238 successes out of 600. And we can verify that going back. Yep. And then make sure that your hypothesis match. So StatCrunch again has P1 minus P2 on the left. Do not mess with this. Always make sure the right-hand side is 0. And then select the proper alternative. So on our paper, we do have a not equal to, so we are good to go. here we find the sample difference. So you just simply subtract P1 minus P2. You get roughly a difference of a 0.09, which we've seen. And here are our test statistics. So let's write those down and wrap up the hypothesis test. All right, so the test here was -3. -3.0994, and the p-value was 0.0019. So right away, because the p-value is smaller than alpha, we can already reject. But let's also visualize this test statistic. So remember, always sketch it on the distribution just to emphasize that this is a sampling distribution. So -3, this value here is -1.9. So -3 is honestly way out here, extremely far off to the left-hand side of the sampling distribution. So we can see that we land in the critical region. So we're going to reject the null hypothesis. And whenever we reject the null hypothesis, we know that we have sufficient evidence to support the alternative. So all we're going to say is we're going to say the alternative in words. You've practiced this before. So this example, I guess we can just quickly sketch it out one more time. So we have sufficient evidence and I'm just going to say at the 0.05 significance level to say, and you're basically just going to say the alternative, which was P1 is not P2, but in words. What do I mean by that? We know what P1 is. P1 is in words at the very top, the true proportion of religious persons who favor capital punishment. And P2 is in words, the true proportion of religious persons, non-religious persons who favor capital punishment. And so we're essentially saying they are not the same. So the true proportion, yada, 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 and the true proportion, so tell me right in P1 and P2 is different. And that is it for our hypothesis test. I actually do want to continue with this. So remember, once you have a hypothesis test, you can also get more information from a confidence interval. So the next part says create a confidence interval for the difference in the proportions. What does your interval say in context? So it's the same command. So let me go ahead and write this out. P1 minus P2 is between, right? That's what it means in context, that the difference, and it'll be equal to, here we're just going to fill in the lower limit and the upper limit that we get. Again, I'm not using formulas. We're just using StatCrunch. So we can go to options and change this from a hypothesis test to a confidence interval. It's at the 95% level of confidence because remember, you have level of confidence is equal to 1 minus alpha, and alpha was 0.05. All right, I'm going to press compute, and we see here our lower limit as well as our upper limit. So let's write that down. I'm only going to stick to 2 decimals, 2 significant digits. So on the other side, we have minus 0.0. So let's keep 2 that are non-zero, 3, 2. So this means that P1 minus P2 is between negative 0.14 and negative 0.32. The most important thing to note from this is that the lower limit and the upper limit have the same sign. So if you have the same sign, that means that you can tell me which of the proportions is higher. So the lower limit and the upper limit have the same sign. In other words, 0 is not included, right? These are both negative. And what this says is that the proportion with that same symbol is larger. The proportion that we see with the minus is larger. And what do I mean by that? Well, let's examine this right here, P1 minus P2. You're always going to be talking about a difference between proportions. P1 in front has a plus. P2 in front has a minus. And so that's what I'm referring to when I say the proportion with that same sign that you see is the larger one. So in this case, the larger proportion is P2. P2 has that minus in there, which matches the minus in our interval. So therefore, we're going to go ahead and say that P2 is larger than P1. And you can tell me how much larger. It's going to be these numbers here. So take the smallest of these numbers. The smallest of these numbers is 0.0032, and the largest of the numbers is 0.14. So P2 is larger than P1 by as little as 0.032 to as large or as high as 0.14. So if we were to translate that into percentages, means that P2 is higher than P1 by about, or by anywhere from, by an amount between 0.032 and 0.14. So in percentages, that means about 3.2% to 14%. So that's a very high difference there if it's closer to 14, 10%. So there is a very significant difference in the proportion here. Okay, so this is what the interval says in context. Well, not quite in context because I'm still using P1 and P2. To actually answer this in context, you would replace P1 and P2 with what those parameters mean. All right, this example is kind of lengthy, so I'll stop here. And this shows you how we are now getting information between these two proportions.